Just turning on the recording.
Sir, I started.
Yeah. Okay. Is it like you can also record?
Yes, sir. Individually, we can record. Also, you can record and then post it in the Google Drive in the classroom, sir.
Okay, if that's the case, then I think one of you can take the responsibility to record it and upload it.
But if any of the students record it, sir, then you have to give the permission to share it. Otherwise, it will be
Mhm.
locked from your Google Drive.
Yeah, I'll do that.
Okay, sir.
I'll do that. Uh, I mean, if it is a CR or any student can do so, just please send me an email. I'll give you permission to upload it. Okay, so please record. Okay, now we will begin our presentation. Did you complete this slide? I think we completed, right?
Yes.
Yes.
Did we go up to?
It's the
Okay,
cables,
okay.
the cable slide. Yes, you completed.
Cable set we completed. Okay, thank you.
Sir, I have a question regarding the
Yeah.
previous question. Sir, you are
Okay.
talking about the
Please go ahead.
cable length. Sir, you are talking about the cable length.
Yeah.
So what's
Right.
actually that mean? Sir, is it like within this cable length, the signal will be like diode or something else?
Yeah. That's the case. In any kind of there are actually two things here. Uh, Normally, you mean that the signal attenuates in any kind of medium. So when it attenuates to a very low level, you can no longer retrieve the information from the signal, and so there is a particular length of the cable through which, with considering uh, some standard level of transmission power, you assume that the uh, power at the receiving end actually it gives you how much loss, what what percentage of loss of transmit power you have in the cable. So in terms of dB, if you are not yet familiar with dB, you will be later in this course. So so depending on that, it gives you a particular length that this over this is the maximum length you can use. Okay, and uh, beyond that the power at the receiving end will be too low. So that's the typical way to declare the maximum length of the cable. But of course, you can still run it longer because you can regenerate the signal at the other end and then again use the same cable. Okay. So this type of regenerator or repeaters are commonly used when you wanna cover a long length. So it's actually okay. Okay. But nevertheless, if you have a longer cable length, then you need fewer repeaters on the way. Another, uh, tricky part here is that in the case of Ethernet, okay, it also relates to delay. Delay, how much latency you have. Okay. Because the in the case of if you're familiar with Ethernet, then you know that the signal you just transmit every. Um, it's open to everybody connected to the particular part of the network. So they all, I mean, every user listen to the medium condition. I mean, you are connected to, I mean, your Ethernet connect card is connected to the hub using the cable. So you just listen the condition of the line. If there is no signal, okay, then you assume that nobody else is transmitting. So then you start transmitting. You put your packet on the line. But what may happen, somebody else actually started transmitting, but because of the latency, you, I mean, his signal was yet to get to yourself. Okay, his signal didn't arrive your point until then. So you thought the line was free, but the line was actually not free. Somebody else started transmitting. Okay, I mean, you're when you're connected to a hub, it's like you all are connected to the same medium, but the delay over the line can uh, make you feel that somebody, I mean, it is free, although it is not. Uh, so you start transmitting. So what happens? There is a collision. Okay, so you both are actually transmitting, and you both fail. Okay, so then the protocol gives you a end of backup period. You both back off, and this backup period will probably be different for you. And so when you retransmit, uh, I mean, the timing for retransmission will be different for you too. So next time, most likely you will be successful in transmission. But again, of course, every time you transmit, you need to listen to the line condition. So here the second parameter, okay, or criterion for you to select the maximum length is the delay of the, I mean the delay of the signal over the line. Okay, so that also gives you the maximum length that you can use. Okay, so if it is too far, then I mean this problem can be even more severe. Okay, so if for a further guy, it will be even more difficult for you to understand that. Uh, I mean, if I mean there are more chances to get into this kind of problem. Okay. So anyway, so basically the two reasons and the two criteria are the the attenuation in the line or losing power in the line, and secondly the latency of the signal. Okay. So anyway, in our I think we can begin our third presentation today. But I must welcome your questions. When you ask, I mean, uh, sometimes you address something which I should have done. Okay, and that helps the whole class. Okay, this time we'll be introduced to the two basic types of wireless link or radio link, namely LOS and non-LOS. So in the case of wireless communication, how does it happen? You launch an electromagnetic wave, okay, using an antenna, and that's the transmitting side. At the receiving end, another antenna catches the signal. So the signal is in the form of electromagnetic wave, and it is also called radio wave. And the link you establish between the two antennas is called radio link. This radio wave is carrying your information. Okay, that's why you have established the link. And remember that the end devices at the two sides, okay, uh, are antennas like them. Okay, so establish a link between them. You can see my presentation, right? Now I'm showing
Yes,
LOS
sir,
and
we can see.
non-LOS.
Yes, sir.
Okay, so the if you have a link like I mean, just assume that if the two antennas had eyes, okay, then they could see each other if there is no obstacle in between, and they are put in a line. Okay, the way you set up is that they face to each other. So, and there is no obstacle on the way. So if that is the case, then you have a line of sight link between them. You you can really draw a straight line between them. Okay. For this type of communication, you use the term line of sight or LOS. Uh, the uh, I mean, there are many examples around. Like whenever you see large dish antennas, okay, uh, is using LOS type of communication. Satellite communication is the best example. Okay, of course, I mean there is no obstacle in between normally. The other option is non-LOS, like your cellular phone. Okay, you probably are inside home now, so the base station uh, you can't see, but it is still communicating. And you, I mean, there are many other examples like TV, radio. All these are non-LOS. Uh, there can be partial abstraction or complete abstraction, but in both cases, it's called non-LOS communication. But it is definitely amazing how you have a communication when there is no direct link, radio link. Okay. When I was a young kid, or okay, I mean, I used to get surprised how the television works at home. So what I did, I closed all the windows and doors in the room where we had our TV. Okay. Now we don't have any TV at our home, but when I was a young boy, we had. So uh, so I closed everything and then turned on the TV, and I found that it was still working. So how things are coming to the TV? I mean, it's so surprised. So the answer is that there are four mechanisms that the electromagnetic wave uses to get to your home or to different places. So these are reflection, penetration, diffraction, and scattering. We'll look into them in more detail later, one by one. We'll touch every item here, but the figure at the bottom probably gives you a quick explanation what they are. In the case of diffraction, you have I mean, from an edge. Okay, like I just have a quick uh, definition type of description here. That in the case of penetration, you have, I mean, the say,
Sir, are you
Um,
changing the
so are
slides,
you
sir?
changing the slide? The slide is still on the first page.
Yes, sir.
oh really?
Yes, sir.
Yes, sir.
Man, how is that? Now what can you say? Is it
Yes, sir.
Yes,
Now
sir,
I
we
can
can
see.
see.
is it different? Okay, when I started presenting, it opened a new window, but Zoom captures the new window itself, but uh, this Google Meet doesn't. Now I understand. So these are the slides I was going through. Uh, okay, first the radio link or radio wave. Okay, then the transmitting and receiving antennas facing each other. Okay, and then LOS and non-LOS. Okay, so in the case of LOS, the antennas face each other. In the case of non-LOS, you may, I mean, it depends. You may sometimes still face, so the receiving antenna may be facing your transmitting antenna. Okay, so they may face each other, but there may be some obstruction on the way, so it is non-LOS. Or there may not be any obstruction, but you are not facing each other. The two antennas are not facing each other. It is still non-LOS. Okay, so uh, the bottom line is you cannot draw a straight line between them when you consider the direction of the antenna. Okay, then you have to be able to draw a line considering uh, the direction in which the antenna is facing. Okay. So now these are the four mechanisms that the non-LOS propagation. Now you can see the four mechanisms, right, guys?
Yes, sir.
Okay. So uh, reflection, scattering, diffraction, penetration. So the penetration, the signal can. It's not surprising. You see that. See if you have a magnet, okay, then you know that you can feel the existence of its influence around. You hold another piece of iron, another magnet, or another piece of iron around somewhere else. You still feel force on it. Now, if you put something in between, say uh, your notebook, okay, between the two magnets, you still feel force. The force will reduce to some extent, but you still have some force on the magnet on the other side. So it means that the magnetic field, is penetrating your notebook. So the field can penetrate. So since the electromagnetic wave is a combination of the fields, electric and magnetic fields, they can penetrate. I mean, the wave itself can penetrate. So, however, it loses energy as it penetrates. If you have a thicker wall, then you have a weaker signal at the other side. So this is why normally when you go far inside, deep inside a building, you don't have good signal. Okay, but there is penetration help you get the signal somehow somewhere inside, but there is penetration loss. I mean, there is a loss of power on the way. Yes. So it can penetrate through objects, but losing some power.
Sir,
Reflection, yeah,
may I ask
yeah.
a question? Sir, we are actually starting from electromagnetic wave. Okay, so
Mm.
what are the backgrounds? I mean, we do need to start this course. I mean, the reflection, the diffraction. Do you need to know about all of this? I mean, I've skipped some of them in higher level, high school.
Okay.
What are the prerequisites
See,
of this?
see. I have a quick presentation, uh, or I mean separate lectures for each of them. Like first of all, I have a presentation called, the title is electromagnetic wave. Okay, so that will be
That will be
I
enough.
mean, I mean nothing is enough here.
Yes, sir.
There is uh, no limit for anything, you know.
Yes,
So
sir. Yes.
then I also have separate presentations for each of these four mechanisms.
Yeah, yes.
Okay, so but none of these presentations I would say is enough. We have to accommodate everything. We have many different things to discuss here. So we'll try to have in the, I mean, I told you in the beginning that this course will, the way I have designed, will probably help you get a clear, an overall idea, okay, overall idea about how things are really going on around in the industries, okay, commercially, how things are working. So you get an overall idea. So you feel comfortable with
Yes.
the communication world. Yeah.
Yes, sir.
And things are, uh, and uh, to be frank with you, I have, I in this course will always be in touch with the industry. I mean, industry processes, and most of the academicians can't present like that. Okay, uh, I have some experience with the U.S. industries, um, and that's why I can do it. Okay,
Yes.
so uh, how things are developing over there, how things are deployed over there in the industries, not in the academia.
Oh, yes.
I have some real experience, and I use that here in my courses. Okay,
Oh,
so
very
you'll
good.
be like say, if I will tell you that it uses the, say, it transmits power here. So if you ask me, okay, then for this application, how much power it uses for the transmitter when it transmits? What is the typical range of power there? I can tell you that. Okay.
Yes.
What are the typical values of different parameters? How things are really set uh,
Industrial
in the
levels.
in the in the in the in the commercial deployment? Okay, I do have experience. I have seen how, I mean, what are the values people use that in the industry. Okay, that people cannot learn from academia. Okay, so that's the key reason for this course to be different. Okay, I mean, this is just the beginning. By the end of the course, you'll feel that it is different from all the courses you have taken so far, and you will be taking. Okay, I mean, my courses will be different. Okay, it will be okay. Anyway, so reflection, I mean, you know what it is, uh, but it can help you get the power. I mean, I mean, ha- have your signal propagating. Like if you are, say, around something, if you're on the other side of a small hill, okay, so a large building may, I mean, the signal cannot penetrate that small hill, okay. So through penetration you don't receive any power, but there may be a building, large building somewhere, which is reflecting signal, and you get significant power. Okay. So you may argue that the power may be very low. Well, in the case of wireless communication, the power is always very low, but you are not transferring power. It doesn't have to be energy efficient. You just need to receive the bits. That's it. It has to be barely enough that allows you to retrieve the bits. Okay. the ones and zeros. That's it. So the power can be very low. If you are still able to recover, it's fine. Okay? Let me give you an example. Since I have told you about the power, receive power, how low the receive power can be, and it still works. Okay, wireless communication is very interesting. See, see the norm, the transmitting power at the cellular base station may be like um, say 1 watt. Uh, 30 dBm means 1 watt of power. Okay, it varies, but it may be transmitting 30 dBm. If you know what it is, 30 dBm, then you can convert. The power is 1 watt. Okay, but when you receive it, it can be very low and it is still working. It can be minus 60 dBm, minus 70, minus 80, minus 90, or even minus 100 dBm. And if you still, your calls can be up even when you are receiving minus 100 dBm power. And if I consider minus 90 dBm, then it is 10 to the power minus 9 milliwatt. Okay, that's the power you are receiving. That's the power, I mean, you have captured in your phone. 10 to the power minus 9 milliwatt. Okay, this much power you are receiving. Just imagine how low it is, and imagine how much, how small fraction of the power you are receiving. The transmit power was not that low, 1 watt, okay, but you are receiving 1 billionth of the transmit power. Your phone is capturing just 1 billionth of the transmit power. So, and it is still working. Your calls are up. Okay, you are doing a lot of things on your phone. So that's why things work. All these phenomena can help you get very small amount of power, and that is sufficient for our purpose. Okay, well, we don't need any bulk power transfer. We just need barely enough power for the information transfer. Okay. Okay, so the reflecting object, if it is large, then you know large amount of power will be transmitted. Also, the type of object, whether it is, I mean, how smooth it is, definitely matter the amount of reflection. Then scattering, it's like when you have, say, if you consider leaves of the trees, okay, so these are uh, scattering power or dispersing the electromagnetic wave in many different directions. Or if you have a surface which is rough, it's not smooth, then the signal when it is incident on the surface will be scattered, will be dispersed in many different directions. Small signals will be just coming out from the surface in many different directions. That's called scattering. Okay, so a little different from reflection. So the scattering object can be foliage, I mean leaves of the trees, the street sign, lamppost, etc. Okay, but it can still help you uh, to reach the receiver. Some amount of power can get to the receiver. Diffraction, as I was saying, that probably, I mean, your physics course uh, gave you some good explanation of diffraction. I mean, at the sharp edge, new sources are created. Many, a good number of small sources are created at the sharp edge, and new propagation starts from there. So that's how you can actually go behind something. So behind this object. Okay. So it's like bending the signal. Okay. But as I told you before, I'll have separate slides for each of them. Now, the key reason for me to introduce this LOS, non-LOS, and word, these three types of communication in the beginning, is to help you get a basic comparison among them. I told you before that, I mean, we, um, once again, I'm repeating that I'm trying, I mean, you'll be prepared for the industries in this course. So when you think of the deployment, then you have to, as an engineer, select the right option. So you'll a lot of times find different options ahead of you, and you have to select. So you need to know the, uh, I mean, the relative advantages and disadvantages. Now you see, for where, I mean, all these comparisons will not be clear at this stage, but we'll just please skim through it. Okay? The connection is dedicated. The transmitter and the receiver is connected through a wire, and nobody else can intervene. Okay, your transmitter sends the signal to just one receiver at the other end when it is wired connection. Okay, you have a particular user connected, so it is a dedicated communication path. So is true for LOS, because I said that the transmitter and the receiver have to face each other, meaning that your transmitter, your transmitter cannot face multiple receiving antennas, right? If you are strictly facing the receiving antenna, then you are definitely facing only one antenna, and so it must be a dedicated communication again, okay, between the two. But in the case of non-LOS, you are not facing, so it is shared, like the base station in the cellular communication is transmitting for so many people in the cell. Your Wi-Fi router is transmitting for all the users at home. So you all are sharing the transmit power, sharing what the transmitting guy is sending. Now, when you are transmitting using wired, you are sending signal, okay, it's dedicated, it is guided to the other signal. So there will be very small amount of power loss on the way, and so the receiving signal will be strong. Okay, so because it has been guided well up to the end, up to the receiving end. Okay, so you receive a strong power level of signal. But in the case of LOS, you launch the power in the air. So the signal is, you don't, I mean, it's not like in the wire, you just put it in the, say, it's like a pipe, okay, the wire. So the wire doesn't, you have a small attenuation, but the attenuation is very low. But here you don't, the signal you don't, disperse it somewhere. But in the case of LOS, to some extent, the signal disperses because you are launching using an antenna. So give me a second, please. So as whenever you use an antenna, you have the signal goes to different directions, at least to some extent. Okay? In the case of LOS, since you know the location of the receiving antenna, you try to confine the radiated power in the air as much as possible. You try to confine, but it is not still completely confined. Okay, but it is pretty well confined. So since it is well confined, it is little dispersed. You get signal which is weak, weaker than wired case, but stronger than non-LOS case, non-LOS or NLOS. Okay, case, because there the power you disperse widely, and that you do deliberately at the transmitting antenna, because you you'll be sharing this power with many different people in the, okay, say consider the base station, cellular base station. All the people in the cell will receive the power. So the base station transmits over a wide range. Okay. So people in different directions can listen. So you heavily disperse deliberately at the from the transmitting end. Now, when you are dispersing your transmit power, then you know the power will be weaker gradually. Okay, you are dispersing, so the density will not be that much. So when you receive the signal, all the users will be receiving, but the signal level will be weaker. That's why I mean I gave the example that the you may receive just 1 billionth power of the transmit power. The third point is interference. Okay, and these things will be better clear. Okay, as we go through the course. The third point is interference, when some other signal is also getting to your receiver. Okay, that's unwanted, but you have them. See, in the case of word, you almost don't have it, because signal, I mean, the outside signal, for the outside signal, it is very difficult to get inside the wire. Okay. For the LOS case, it is in, everything is in the air, so it is possible that some other signal is. But if you consider that everybody is using separate frequencies, then, well, you should not have normally. However, what you may do, you may have leased some frequency. You have some permission to use some frequency range, so that you may be using in different LOS establishments. You may have multiple LOS setup, and you are using the same frequency range there. Since all this setup uses well confined, okay, one setup should not have, okay, I mean, much of the power of one setup does not get to another setup, because you are confining well. Okay, so but there may be still some power going to some other setup. Somebody else may be using some frequencies close to yours. It is coming to you. So since it is air, you will have some interference, but not too much. Now think about the non-LOS case. What happens? You yourself maybe, I mean, you have some frequency range for, I mean, permitted for use, and you are using it in many different base stations. But these base stations are transmitting power over a wide range, to support many users around. So one base station will actually send some power to another base station too, although that's not desired, but that will happen. While covering its own users around, it can't stop its signal, and some signal will get to another cell. And that's how in the system there will be many base stations interfering themselves. So when you are dispersing widely, there is no easy way to stop the interference. You'll be you'll have so on one side you have weaker desired signal, on the other side you have stronger undesired signal, and the ratio of these two is SINR, the fourth point. Desired signal over undesired signal is called signal to interference plus noise ratio. Okay,
Sir,
we'll have more, yeah. Yeah.
when we are talking about interference, so when you disperse the signal, sir, there are lots of surfaces in the region. So doesn't it interfere with itself? I mean, suppose a signal is reflecting from a building and another signal is reflecting from the opposite building, and they are interfering with each other. Doesn't that happen? I mean, itself.
It does. Definitely.
Hmm.
Definitely. It does
Isn't it a
happen.
problem?
Yeah. That's the best question uh, in the class today, definitely. Yeah. You are absolutely right. That's why non-LOS case creates an environment which is called multipath environment. A particular signal gets to the receiver through many different versions of it. Okay, you'll have many different versions of the signal via all the four mechanisms, and these signals uh, work. I mean, they are uh, inter they interfere each other, but only when they are not time aligned. Okay. I mean, these different multipaths take different delays.
Mhm.
When the delays are different, then they interfere. Okay,
Understood.
we'll later show that it is called intersymbol interference, ISI. But if two versions arrive at the same moment, then it is
Mhm.
not
Oh, yeah.
interference.
Yeah,
Then you sum up the signal.
some of this.
Yeah, okay. Then you are summing up the signal. That will be advantageous for you.
Mhm.
But intersymbol interference can be problematic for you. Okay.
Yes, sir, I got
However,
that.
however, there are some mechanisms which can combine uh, some of the versions which are time delayed, okay, not time aligned, constructively. Some advanced receivers can do that, and every receiver can do that to some extent, but advanced receiver can do that more constructively. Then you still get benefit out of it. Okay, it is not, instead of creating problem, you still have more power. Okay, okay.
Yes, sir.
Anyway, so SIN. Okay. Now the next point is available bandwidth. Well, see, you have um, see in the non-LOS case. Okay, let's give you the worst example first. Uh, the bandwidth, the I mean, since you have this interference problem, you yourself interfere another base station. The way, one of the ways to solve is to split whatever frequency range you are permitted. Okay, and then once base station will use a part of it. I mean, we'll look at it in more detail later, but I'm sorry, I'm just reiterating it. But this is a very quick comparison that we need to, I mean, that will help us uh, in the later discussions. So, but it is too early to have this comparison. So I'll be hinting only now. Okay, so it splits the available bandwidth and allocates to different base stations in the neighborhood, in the among the nearby base stations. Okay, so the other base stations around yourself will have different frequency ranges. Okay, then again repeat. Whatever you are using in your base stations will be repeated at a base station, but that is little bit far. So that's how you mitigate the interference. But as you split your available bandwidth, you get a smaller share of the bandwidth. So you have lots of challenge. Also, there, I mean, many other people will also be using the air, so they will have their own frequencies. So that's how you are getting very restricted about how much bandwidth you can get. Okay, the air is for everybody, and you are using this resource, this common resource. Okay, the air. So you'll get a very small share of your frequency range. Okay, and this bandwidth directly, actually linearly, impact your data rate. You have larger bandwidth, you have okay, like in Bangladesh, the major mistake of the policymakers is that they, I mean, they have made some. I mean, the policies are like the cellular operators cannot afford enough bandwidth. Okay, so if the government could relax and the operators could lease more bandwidth, then we, the customers, would be benefited. Our data should be a lot higher. Just this way, it could be made 3 times, 4 times, 5 times higher. Okay, so we would get the benefits. The revenue would also increase for the government, but they don't. I mean, uh, this hard policies doesn't help anyway. It's not like, I mean, it's all in the air is open, right? You have all the frequencies available for free. Why just leave them idle? Why you don't? I mean, you if it was used, you could get benefit out of it. Okay, it's not like your natural gas or coal. Okay, that if you don't allow people to use it, then you can preserve it for future use. No, so there's no point to make hard policies here. The policies could be, I mean, you could make these things very cheap so that the operators would afford. Okay. No, I'm not advocating. Don't think that I have received bribes from them, but that's the reality. Okay, so the bandwidth is now for LOS communication. Since you are confined, okay, so a large share many people will be able to use the same frequencies because you are confining your radiated power. Okay, so you're not interfering. So if you use large bandwidth, okay, it is not uh, disturbing others. Okay, so higher bandwidth. But in the case of wired, I mean, you can even see in the case of optical fiber, it is in the order of terahertz. Very large bandwidth you can use. You have dedicated communication. The wire has some capability, maximum capability, that will restrict the upper limit of your frequency. Okay, so you have wide bandwidth. It's extremely large. Now the final point. Actually, that's the final point here. Really, the other points are the points below are different aspects. The data rate, how much data is. So that's the crucial outcome. So the data depends on primarily on available bandwidth and SINR, these two things, as we will later show in Shannon's capacity formula. These two things affect how much bandwidth and how much SINR. So if you have, now you see that in the wired case, you have very high SINR, because SINR is the ratio of received signal and interference. So SINR is very high, bandwidth is very good, so very good data rate, extremely high data. For LOS case, bandwidth is compared to non-LOS case is higher, It is somewhere in between for both SINR and bandwidth. So the data will also be well placed in the middle. And non-LOS case is the worst case. Okay. So non-LOS case is the worst medium for us. Quality of service, okay, these things are, again, you'll see that, I mean, will be easier to maintain for the wired case and LOS case, okay. Eavesdropping, somebody else overhears your signal, okay. In the wired case, they cannot, okay, they cannot, I mean, you have dedicated communication within the wire, so I can do the, in the LOS case, it is in the air, signal is in the air, so there are chances, but slim chances because your power is confined within the region. But in the non-LOS case, you are dispersing your signal. You're just releasing it to, you're leaving it open to everybody. Okay, so unless you have some spatial measure, everybody can hear the signal. So unless you have some special measure, they will also be able to retrieve the bits. So eavesdropper better. Okay, but we'll later address these things. Installations, okay, it can be cheap or expensive. It depends. It depends. Okay, which one will be cheaper? Depends. So that there are many different types for all these types of established installations for all of them. Okay, so it's not easy to compare at this point. Okay, now as we have seen so far, the third column gives you the worst performance. So why we go for it? Okay, and in this course, mostly we will address the third column, non-LOS case. And cellular communication is my actual focus, and that's an example of non-LOS communication. So as I said, that I offer a course dedicated on cellular communication in the next semester. So, but you can see that it has everything worst. So why we go with it? We just drop it. We should just drop it, right? But
Custom.
we don't do that. But you cannot drop it because you know there'll be exam in the different mid exam, final exam class tests, and you say that I'll be covering non-LOS case, so you can't drop it. You have to
So
get
most
through
of the questions will be NOLS. I mean, wireless.
that. Yeah. So,
Do you expect more questions from that part?
yeah,
sir,
definitely,
is
definitely.
implementation
Mostly,
in real life, sir? So is
yeah.
implementation in real life, sir? Is it significant, sir? Like, is it important?
But why? Why you implement it in real life is the problematic one. Yeah, okay.
So
That's the
for
last
the
point.
last option, mobility.
Yeah. You don't support mobility with
So
the other thing.
cost? Is
Right?
it the cost?
Yeah. I mean the installation cost, yeah, the maintenance cost can be also can matter, but that depends on the topology of your deployment. I mean how things are set up. Okay. So anyway, so the key point is that you can move when you are not connected. Okay. In the first two cases, you cannot move. So when you are a human user or this type of user, some automated devices also, when you want to support mobility, then there's the only option. And this is becoming a requirement in many applications. Okay. But at the last part of your communication network, okay, at the final part, so at the last segment of your communication part, you need this option. But there are many other segments in the whole communication. We'll have a presentation in our first lab class. We have a lab class this afternoon. Okay, so I'll have a presentation there. I mean, a presentation from YouTube to help you get an idea about how the whole communication network forms.
So you're telling that for a complete transmission of our data, there may be many segments which uses different,
Yeah.
which
Yeah.
uses both the
So
wired, the
like
LOS.
you may be talking to your friend in USA. Okay.
Yes.
So there are many segments on the way.
There are
But
many
at the last
segments.
part, you are connected to a base station. You're using your cell phone. So only in this last part, when you are
Mhm.
connected to a base station, you are using non-LSKs. So you can move, you can roam around. Okay.
Uh,
But for the other segments, you don't care. So in
uh,
the other segments, it will be either wired, preferably wired. If
mm.
not possible wired, then it will be made LOS.
Yes, yes.
Now you got it?
Yes, sir. Yes.
So they will prefer wired. If wired is not possible somewhere, it will be LOS. Okay.
Sir,
So
is
yeah,
the connection between two phone towers LOS, like two Grameen phone towers?
it depends. It depends. Us uh, discuss different things. Okay, in our later. Okay. Any other questions?
No, sir.
Okay.
Yes.
So these early presentations are some basic things which I will different times mention at different stages. I'll be uh, just I'll cite different things, different examples, and all that. So I need this idea for you to have. Another uh, the next presentation also has the same purpose. That okay, see the last example. Okay, non-LOS case has the most challenge. Okay. It's a oh, a second.
Sir, one more issue. Can you address? So today the attendance, sir. How will you take it?
I thought Google Meet keep the
Keep
record.
that record. Oh,
It doesn't?
I don't know actually.
Sir,
Does
as
it?
far as I know, it doesn't, sir.
It doesn't, sir, actually. Yes, sir.
Oh, really?
Yes, sir.
Oh, okay. Hmm.
Sir, one more thing. You said lab is on today afternoon. Actually, the lab is on tomorrow, right?
Oh, tomorrow.
Today,
Yeah, right, right. It is tomorrow. Okay, so
Sir,
we.
I had a small question, sir.
Mhm.
So when we're saying say NLOS, right, sir? মানে, when we see that multiple data are being transmitted between the station, receiver, and the transmitter, right, sir? In case of NLOS, right, sir? So,
Yeah,
uh, so is it kind of like the bandwidth is being shared by multiple data? Are we saying that?
yeah, yeah. It is like that.
So it's like between the transmitter and the receiver, the
Yeah,
entire bandwidth is shared by different signals.
different people. Yeah,
But
it is just
unlike our normal LOS or wired
yeah.
case where only a
But
signal data
but
is transmitted.
but I
Yeah.
mean, uh, the answer will be. My next presentation will answer it more correctly. Okay, but if I have to take your attendance now, then I have to call each of you.
Sir,
We can end today's actually, sir. Let's start
Mhm.
tomorrow fresh or next day fresh, sir. And you take the attendance, sir.
Yeah, maybe I consider everybody present today. Okay,
Sir, around 60
so
people.
today I just consider everybody present, and from tomorrow. But one of the reasons uh, I selected Google Meet, I mean, I thought there's a
Sir,
code
sir,
of
there is a
that.
way, I think, sir. Like, sir, in the right side you can see the menu, and in the menu there is settings, and from the host controls you can like turn on and off attendance tracking. You can check it, sir.
Oh, really? Okay.
So the three dotted line on the right side.
Yeah, yeah. Mm, I don't see. Well, by the way, some of you did not use your ID last time. I'm not sure how it is today. Your you should please include your ID in the way you appear here. Okay, so I can identify who is present and who is not. Okay, most of
So
you had it like that, but 3 or 4 people did not have ID in the display.
for today, please consider everyone is present. From the next class, will be.
Yeah, yeah, yeah. But I thought I'm surprised there is no option like that. Okay, anyway, so in the next
Sir,
presentation, I will,
hello, sir.
yeah.
Sir,
Mhm.
there is a browser extension that you can separately install. It is
Okay,
available in the web store, Google Chrome store. So it is named the, I think, Meet Attendance. So if you install it,
okay,
it will automatically add the option to take the attendance.
okay,
You can
okay.
just
Just
search
please
it.
send me, then please do me a favor. Send me a link of this.
Okay, sir. Then after the class, I can send you.
Okay, okay.
Okay,
Thank
sir.
you very much.
Okay, sir.
Okay, then uh, my presentation. Oh, I can I get to that? The problem is, uh, I, c- I mean, when I go to the display, it is taking a different window for me. Sorry, but it's not taking me there. Why?
Sir, if you share the entire screen, then that problem will be solved. Maybe you are
Okay.
selecting to share a tab.
Okay. Okay. Do you see the slides now?
Yes, sir.
Okay. Is it like is the title like currently developed cellular technologies?
No, sir. Evolution of cellular technology.
Hmm. See, how can
Can we start a new thing tomorrow, sir? We don't have a lot of time left.
I? Yeah. then Zoom seems better.
Yes, sir, it is, sir, to a certain extent.
We'll go back to Zoom next time. Okay.
Sir, you can check the link, sir, in the chat box. You have to install that one.
Okay. So well, anyway, we'll go back to Zoom next time because it's not okay. Uh, okay, let's see. Okay, now this presentation discusses the evolution of cellular technologies. I need to discuss this part because I will be a lot of times, as you said that, I mean, we will be mostly discussing non-LOS case because it involves the real challenges, most of the real challenges. Wireless communication, we have to learn how it works. It takes care of different issues. And these issues mostly you find in non-LOS case. Okay. So the discussion covers, I mean, things are more comprehensively covered in non-LOS case. And the most complex example of non-LOS application is cellular technologies. So to discuss different techniques or methods, when I give you examples, okay, mostly I'll have to give you examples from these cellular technologies. And to mention this technologies, it is better for me if you are familiar with at least. Is anybody saying something?
Sir, sorry to interrupt. We have class at 10:30.
10:30. Okay, but
Sir.
I think I have three minutes. Okay, so I'll finish in 3 minutes anyway. So if you are familiar with the different generations, okay, how, because you know that there are many different terms, like you also see at the on your phone different symbols like G, E, 3G, H plus, 4G. So what they mean, what technology you are actually running. Okay, so we'll just touch base on these things in our next class, inshallah. WiMAX was there, okay, but later, I mean, these are the mainstream cellular technologies nowadays. Okay, so I wrote the book on LTE. Okay, I mean this part, and in the cellular communication course, I now cover 4G and 5G. These technologies I cover. Okay, we'll go from here the next day. Any questions?
Yes, sir, a few, sir. Inshallah, sir, next day I'll ask you, sir, but the other class now, sir.
Okay, okay. Okay, then bye for now.
Thank you, sir.
Thank you for your time.